Let us discuss about finding the inverse of a matrix. So for matrices, there is no such thing as division. So you can add, you can subtract, you can multiply matrices, but you can't do division with them. So there is one related concept though, which is called inversion. So the technique for inverting matrices is kind of clever. So for a given matrix A and its inverse, we know that the product of A and its inverse is equals to identity matrix. So we're going to use the identity matrix in the process for inverting a matrix. So let us have an example. So suppose we have A is equals to 1, 3, 3, 1, 4, 3, 1, 3, 4. So we have a 3 by 3 matrix. So first, I write these entries into a double wide matrix. So we have this double wide matrix. So I write the entries of the given matrix in this side. So we have 1, 3, 3, 1, 4, 3, 1, 3, 4. Then on the other side, I write the identity matrix. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, I'll do matrix row operations to convert this left-hand side into identity matrix. So as always with row operations, there is no one right way to do this. So what follows are just the steps that happen to occur to me. So your calculations could easily look quite different. So as you can see in the first row, so it's already 1. So let us just copy the entries for row 1. So we have previous row 1 is equals to new row 1. So we have 1, 3, 3, 1, 0, 0. Then as you can see in the row 2, so it's 1. So let us turn this 1 to become 0. And we need to add negative 1 to become it 0. So for this reason, so we have negative 1 times new row 1 plus previous row 2 is equals to new row 2. So we have negative 1 times 1, that is negative 1, plus 0, plus 1 rather, that is equals to 0. So negative 1 times 3, that is negative 3, plus 4, that is equals to 1. So negative 1 times 3, that is negative 3, plus 3, that is equals to 0. So we have negative 1 times 1, that is negative 1, plus 0, that is negative 1. So we have negative 1 times 0, that is 0, plus 1, that is 1. And then negative 1 times 0, that is 0, plus 0 is equals to 0. Next, as you can see, the same as in row 2 in previous. So the entries for row 3, so we have 1 also. So the same, we have negative 1 times new row 1 plus previous row 3 is equals to new row 3. So we have negative 1 times 1, that is negative 1, plus 1, that is 0. So negative 1 times 3, that is negative 3, plus 3, 0. Negative 1 times 3, negative 3, plus 4, that is 1. And we have negative 1 times 1, negative 1 plus 0, that is negative 1. We have negative 1 times 0, 0 plus 0, that is 0. And we have negative 1 times 0, 0 plus 1, that is 0. So next, we have, so as you can see in row 2, so it's already 1. So let us just copy the entries for row 2. So we have previous row 2 is equals to new row 2. So we have 0, 1, 0, negative 1, 1, 0. And as you can see, it is 3, right? So we are going to turn this 3 to become 0. And we need to multiply negative 3 to the new row 2. Then plus previous row 1 to get the new row 1. So we have negative 3 times 0, that is 0, plus 1, that is 1. So negative 3 times 1, that is negative 3, plus 3, that is 0. Then negative 3 times 0, that is 0, plus 3, that's equals to 3. So we have negative 3 times negative 1, that is positive 3, plus 1, that is 4. Then we have negative 3 times 1, that is negative 3, plus 0, that is negative 3. So next, negative 3 times 0, we have negative 0 plus 0, that is 0. So next, as you can see in the entries for previous row 3, it's already 1, so let us just copy. So we have previous row 3 is equals to new row 3, 0, 0, 1, negative 1, 0, 1. Next, as you can see, so we need to just copy the entries for row 3. So we have previous row 3 is equals to new row 3. So we have 0, 0, 1, negative 1, 0, 1. Then as you can see in the previous entries for row 1, it is 3. So we need to turn this 3 to 0. And the same, we need to multiply negative 3 to new row 3, then add to previous row 1. So we have negative 3 times new row 3 plus previous row 1. Negative 3 times 0, that is 0, plus 0, 0. Negative 3 times 1, negative 3 plus 3, that is 0. Then we have negative 3 times negative 1, that is 3, plus 4, that is 7. So negative 3 times 0, that is 0, plus negative 3, we have negative 3. Negative 3 times 1, that is negative 3, plus 0, it is equals to negative 3. Then, we have, as you can see in the second row, so it's already forms identity matrix. So I just copy also the previous row 2 entries. We have previous row 2 is equals to new row 2. So we have 0, 1, 0, negative 1, 1, 0. So as you can see, in this left hand side, it is now an identity matrix. So therefore, our inverse is the entries in this side. So we have, so that's why the inverse of A a while ago is 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1. It is now the inverse of A.
Product of A and its inverse is equals to identity matrix. So note that we can confirm that this matrix is the inverse of A by multiplying the two matrices and confirming that we get the identity 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, 1, multiplied by 1, 3, 3, 1, 4, 3, and 1, 3, 4. So now we are going to multiply the two matrices. So now we have 7 minus 3, and then 21 minus 12 minus 9. Next is 21 minus 9 minus 12. For the next row, we have negative 1 plus 1 plus 0. Next, negative 3 plus 4 plus 0. Then, negative 3 plus 3 plus 0. For the last row, we have negative 1 plus 0 plus 1. Then, we have negative 3 plus 0 plus 3, negative 3 plus 0 plus 4. So we come up with 7 minus 3 is equal to 1. And then 21 minus 12 minus 9, we have 0. Then 21 minus 9 minus 12, we have 0. So for the next row, we have negative 1 plus 1 plus 0, we have 0. Negative 3 plus 4 plus 0, we have 1. And then negative 3 plus 3 plus 0, we have 0. Then the last row is negative 1 plus 0 plus 1, we have 0. Negative 3 plus 0 plus 3, we have 0. And then negative 3 plus 0 plus 4, we have 1. Now, we can confirm that this matrix is the inverse of A by multiplying the two matrices. Be advised, in real life, the inverse is really a matrix filled with nice, neat, whole numbers like this. With any luck, though, especially if you're doing inverses by hand, you'll be given nice one like this to do. Thank you for watching.